technical advisory groups, the AIA Committee on the Environment Shared Elect, and as a steering committee representative for the Climate Heritage Network. She holds a bachelor's degree in architecture and a master of engineering in high performance structures from MIT. We're very, very excited to have you here, Laurie. The stage is yours. Laurie, I think you should ideally be able to control this. It's not happening. I know. Oh. Yeah. Okay. All right.
All right, thanks. Hi, everyone. It's really exciting to be here today to talk about this, and thank you for the wonderful introduction to circular economy. I think that was excellent framing and a great lead-in. And so I am here to talk about buildings, that really large, the largest objects we have, and how we can think about reusing them as a really integral way towards moving towards a circular economy. So why existing buildings? We have a lot of them. Here in the United States, we have over 340 billion square feet of existing buildings, and 2/3 of those will still be here by the year 2050. We know that a lot of these are not performing with high energy efficiency, and a lot of them are, contributing to other factors such as human health and poor environmental situations as well. At the same time, we know that only 2% of our existing building stock is renovated annually. That is not enough. As you'll see in a minute when we talk about emissions from the built environment, we need to rapidly accelerate this number to reduce the emissions coming from our built environment. And then we have this third consideration, which is historic buildings. And typically we think of historic buildings as, old 200, 300-year-old buildings with masonry, and they could be museums or landmarks, but really historic buildings are anything older than 50 years old, which is now 1972 and older. So we're talking about a lot of our mid-century heritage, including brutalist buildings here in Boston. And these lead to another kind of facet of challenge when we think about how to reuse these in a more sustainable way. And then zooming out to global emissions, globally, buildings represent 37% at least of all emissions coming from energy use. And this is really broken down into two sections here. First, operational emissions. These are the emissions that come from using our buildings. And these are mostly from using existing buildings. So this, whoa, I feel like these are advancing. Sorry. This 27% of global emissions really needs to be tackled by retrofitting and upgrade the buildings we already have. We also have, though, 10% of global emissions from the materials that go into construction. These are the embodied emissions, as previously described, that come from that material extraction, manufacturing, transportation, et cetera. And this is mostly from new construction. And so when we reuse existing buildings, we have the opportunity to both reduce the operational emissions from operating our built environment and avoid those emissions from new construction. And this is especially important when we think about the time value of carbon, the time frame in which we need to decarbonize. I think we're all aware that this is the critical decade now. We don't have time to look for decarbonization strategies that pay back over the full life cycle of a building. We have to be looking for strategies that pay back now, that reduce carbon in the very near term. And so that's where existing building reuse comes into play, because of those especially early upfront reductions in carbon. And then I also just want to remind us all that it's not just about carbon. We talk about that as a metric for global warming, and it's hugely important, but there are obviously other impacts as well. Thinking about, for example, raw material extraction, which is responsible, this is advancing. It's on. Which is responsible for over 90% of biodiversity loss. And here in the United States, the construction sector is responsible for 3/4, 75% of our raw material extraction. And there are also social implications to this as well, thinking about local jobs, local economy, and the health of our local communities. Reusing and refurbishing an existing building produces approximately 300 jobs for 10,000 tons of waste. And you can compare that to a traditional process of demolition, which results in only 1 to 6 jobs for the same amount of waste. So really thinking about the effects and the benefits beyond just those that can be measured in carbon emissions. All right. So I'm going to go through one case study now. This is a building just across the river, the admission center over at BU. This was a comprehensive renovation that we did in a number of years back now. But you can see this was a mid-century building, one of the few buildings in Boston built in a modern style. And it is part of the historic landmark district. So you can see that the exterior was largely preserved in the original character. This project was a complete renovation of the interior. You can see here, it kind of, we needed to bring this building forward in time, make it more welcoming, make it more transparent, and more contemporary. As you can see on the left, or in the bottom left, the old building was sort of closed in and still had most of its original fabric. And the renovation really just brings it up to its current status as an admission center. So the interior was completely rehabilitated. The exterior, as I mentioned, was really kept intact primarily. But with most building, as with most building reuse examples, there was some addition that occurred. And so this is sort of part of the balancing act, is reusing as much as you can, but making these buildings still relevant. So for example, this included a small entry canopy, as well as a new mechanical penthouse and an addition on the north to help create that transparency and additional circulation. So through the course of this renovation project, we were able to really improve the performance of the building. So this is that step one of reducing emissions, is reduce operational emissions. So since we were doing this comprehensive level of renovation, we were able to get in there and add insulation to the interior face of those historic walls, to the roofs. We replaced all the glazing systems with high performance glazing and all new high performance systems and building controls. But throughout all this, we were able to preserve 86% of the structure and enclosure. And this number is significant because the structure and enclosure are the two parts of the building that do have inherently the longest life and the highest embodied carbon. So this is where we're really trying to extend the life of those systems as long as possible. And as a result of the project, we were able to reduce the annual energy use by 58% below the ASHRAE code baseline. And so that's a really huge reduction of carbon emissions annually, which will accumulate over time. And then on the right, I also just want to note that in addition to reducing energy use, we were able to move a lot of the systems over to electricity. And this electrification is another key point here as we think about moving away from fossil fuels and moving towards clean energy sources. Being able to convert historic and existing buildings onto electric systems is a really important step of how we reuse buildings and extend them. And so in addition to that sort of long-term operational carbon savings, we also wanted to understand the upfront carbon investment of the renovation. And so these are the results of a whole building life cycle assessment we performed, which measures the cradle to grave impacts of the materials going into the building. And we get a number here of approximately 270,000 kilograms of carbon dioxide equivalent. And we can also compare that to a new building. Again, this is looking at the avoided impacts of being able to keep these materials in use rather than demolishing and landfilling and replacing with new. So you can see the really dramatic reduction in embodied emissions. And these are the emissions that are mostly upfront that occur before anyone even moves into the building. And we can also look at where these emissions in total occur over time. So cumulatively, if we look at the unrenovated building, if we've done nothing to it, there would be no embodied carbon at the year 2014 when this building, when the renovation opened. But it operates and emits a lot of carbon dioxide every year at about a steady rate. We can then layer on the renovations. So you can see a small jump in embodied carbon at the year of renovation, which is that sort of upfront carbon debt incurred for the renovation, but the slope is really reduced. And that represents the improved energy efficiency. So every year, it emits less carbon than the unrenovated building. And this yields a carbon payback of only 4 years. And I think that's a really important metric as we think about we can't keep everything in service, but to think about how much we can reuse and what is the carbon payback time of the debt of the embodied carbon we spend to reuse buildings. And then we also, it's important, I think, to show the replacement building scenario, because we do always hear the argument, wouldn't it be better to just tear it down and build a high performance net zero new building? And this really illustrates the answer to that question is no. Even if we give this replacement building a 10% improvement in energy efficiency, the upfront carbon debt of embodied carbon is so great that those two lines, the orange line and the blue line, never cross, meaning that through the year 2040, which is the carbon neutrality target year for that university, the renovation will result in a lower total carbon emissions. And then getting back to that point about electrification, we know that the grid is not static. It is getting greener. Here in Massachusetts, we have a commitment to an 80% reduction in our grid emissions by the year 2050. So once we factor that in, if we can bring our existing buildings to be powered through electricity or through clean energy sources, that slope goes to zero, meaning that the operational emissions go down to zero, making the embodied carbon much more proportionally important. So as those slopes all kind of level out, you can see that the renovation becomes the lower carbon option, not just in the near term, but also in perpetuity in the long term. All right. This automatic advancement has really kept me on pace here. So I just wanted to end with a few resources here to share with you. If you're interested in learning more about embodied carbon, I would highly recommend checking out the BSA's Embodied Carbon 101 series, which is all available on our website. And if you're interested in learning about this intersection of cultural heritage and preservation and climate action, check out the ZNCC, which you can join and participate in, and the Climate Heritage Network, which is working at a global scale, bringing together groups who are tackling this issue. And with that, I will thank you all.
Thank you, Laurie, for that very thought-provoking presentation. I personally was going to ask you about how a renovated building will actually play out with a green building if we were to demolish it. So thank you for introducing that concept. Our second speaker for today is Professor Catherine Deworth. Unfortunately, she will not be able to join us in person, but we do have her on video. As Assistant Professor of Circular Engineering for Architecture at ETH Zurich, Professor Catherine Deworth conducts research on digital innovation towards a circular built environment. She has a dual background in civil engineering and architecture from Belgium, obtained her PhD in building technology from MIT, and worked for the University of Cambridge, the Swiss Federal Institute of Technology Lausanne, the European Commission, and TU Delft. She collaborates closely with pioneering design firms such as Arup, Rotor, and Bobero in situ. I really, really hope that you enjoy this video of her approach on reusing building materials.
Hi, my name is Catherine de Wolf, and I'm Assistant Professor of Circular Engineering for Architecture at ETH Zurich. I work on exploring digital innovations from other sectors and bring it to the construction sector in order to move from a linear model where we extract, make, use, and waste our materials towards a circular model in which we reuse our waste materials as a resource to close the loop. I had the chance to work in the engineering office called Elliott, which was responsible for the renovation of the Centre Pompidou in Paris. All the beautifully bent glass needed to be replaced. Surely we could find an architect who wanted to reuse this glass, right? So after spending some time and energy, we finally found a designer firm called Maximum with a client who needed this type of glass right in time. It's relatively rare today that the end of life of one building or building material aligns with the start of life of a new building. To be able to move towards a circular construction industry on a large scale, not only for iconic buildings such as the Centre Pompidou, but for all buildings, we need data on when and where materials will become available for reuse. We need information on these materials before a building gets demolished. We need adaptability and expertise for careful disassembly and sorting of the materials. We need to identify, track, trace, and trade those materials more efficiently and transparently. And we need to change our way of designing and looking at buildings completely. Could digital technologies help us save not only the glass from the Centre Pompidou, but also all other materials and resources for other buildings worldwide? Could digital innovation help us reuse materials in a much faster, quicker, and cheaper way than ever before? Only then will circular construction be competitive enough so that we can abandon the current linear model.
We're doing research on circular economy in buildings and on digitalization that can help us to do so. But we really want to know also how it is applied in real case studies, and that's why we built this dome. We went to a building in Geneva that was about to be demolished, and then we disassembled the materials that we were reusing for this dome.
First, we need data to predict when materials will become available for reuse in a city. We can use AI and more specifically machine learning in combination with big data analytics. Google Street View images, social media images, or national demolition records can enable us to predict materials becoming available in demolition projects. Algorithms can identify patterns in the data to make these predictions. For example, we have developed machine learning techniques for detecting windows available for reuse from Google Street View images in combination with cadastral data for the city of Zurich. Second, we need information on these materials before a building gets demolished. To do so, for the old car warehouse in Geneva, we use photogrammetry to form point clouds based on drone imagery, as well as LiDAR scanners. We also use computer vision to recognize which materials were scanned and in what condition they are. This enabled us to build a BIM model and a material inventory for the building. Third, we needed to disassemble the building, sort the materials, and adapt them to the needs of the new design. To do so, we can use robotics and other digital fabrication tools. Of course, we're not at the stage yet where we can ask robots to disassemble an entire building, but we do use robots to sort materials in recycling facilities already today. We could imagine these types of robots helping not only with recycling, but also with the reuse of building materials. In the dome project, we used computer numerical control or CNC milling to adapt the materials we had to the needs of the dome greenhouse.
Once we were assembling the dome, we realized that we needed some new materials to adapt to the shapes that we had. To do so, we used digital fabrication techniques. For example, we used CNC to cut specific shapes that adapted to the pipes that we found in the building in Geneva.
Fourth, we need to distribute the materials.
We engraved all of the materials that we found with QR codes so that we can track and trace them throughout their different life cycles.
When you scan the QR codes on our dome elements, it leads you to an online database with information about this element, the type of material, the dimensions, where it was before, in which building it is now, and so on. This is what we call a material passport of a building. This enables us to know exactly what materials and how much there are in the buildings right now, so that we can use them as material depots, as material banks. When the building gets demolished or renovated, we can know exactly which materials could be reused in the future. We can use the building as a material mine instead of the earth. Fifth, we need to optimize the design of our new building based on the available stock of materials we have found in Geneva.
With the inventory, we made a design thanks to computational design algorithms. Throughout this dome project, we really explored digital innovations from different sectors and brought it to the construction sector.
We will definitely be bringing Professor Catherine Deworth in person at our future events to discuss more about her material passports. Moving on, our final panelist and speaker for today, Julie Janesski. Julie is a partner at Bureau Happel, based in Boston, and a leader in integrated and sustainable design. Known for merging design, consulting, and analysis to champion regenerative design in the built environment, she directs projects at all scales, achieving sector-leading levels of carbon reduction and water conservation, as well as social equity and human health and well-being. Julie has managed and delivered some of the firm's most cutting-edge work on the path of decarbonizing the built environment, including analysis and implementation of all electric systems, citywide carbon planning, writing climate action policy, and more. She holds a Master of Architecture from the University of Michigan and a Master of Design Science and Sustainable Design from the University of Sydney. Please join me in welcoming Julie Janesski.
Hello, everyone. Thanks for joining us today. I don't know how I can possibly follow that video. It was absolutely incredible. Thank you. So I had a really good feeling that Lori was going to be talking about carbon and embodied carbon and operational carbon. We do a lot of work together in the industry through the Carbon Leadership Forum and some other organizations. So I thought I would spend a little bit of time talking about water as another version of a material and the way in which we think about that in terms of a circular economy. I think the premise of the slides that I have today is trying to get at the idea of circular economy and systems thinking, and the way in which we use that to try to think about where the boundary starts, where it ends, what we're doing, what other people are doing, and ultimately raise a lot of questions without so many answers yet. In terms of the water cycle, we are taught very early on that the left-hand side of the screen is good, the right-hand side of the screen is bad. The natural water cycle is self-sustaining. It is ultimately circular. And on the right-hand side of the screen, we're extracting water, we're treating it, we're using it, and then we're dumping it wherever we please. And it's not really fulfilling the idea of the natural water cycle. That said, the urban man-made infrastructure systems for water happen for a reason. There was a lot of health issues in history without having this type of infrastructure in place. So we know that it was done for a good reason and it solved a lot of problems, but it's also started to create some that I think a lot of people are thinking about now. So another way of looking at that is the difference between the left-hand side of the screen being part of that natural water system, and on the right-hand side of the screen, an urban system where the same amount of precipitation is coming down to the site, but a lot less is infiltrating and a lot more is running off. And that has a huge impact on the natural water systems and the way in which they are or are not circular. So we've been working on quite a few projects lately where we're trying to understand the difference between moving from the sort of what you're allowed to dump in storm sewers and sanitary sewers and what you're allowed to take from the city as potable water supply, all the way to the right-hand side of the screen, where there's an understanding of trying to look at net zero water in buildings. So zero discharge to the city, zero potable water from the city, a standalone building, you capture your water, you treat it, you reuse it, you keep it on site and infiltrate it to try to create this sort of microcosm of a circular economy of water on your site. And there's a lot of good that can come from that. This is one of the studies that we did for a US Embassy project, looking at exactly that question, to eliminate the potable water being used from the city and to look at all of the rainwater coming onto the site, how much of it could be used for potable purposes, how much of the gray water and black water could be used for non-potable purposes, and then how much was available and or needed to be maintained on site for on-site wetland or detention. Another example of this at a much smaller scale, but relatively local, in Amherst, the Hitchcock Center for the Environment excuse me, is a living building challenge. So it is actually net zero water. It fulfills the question of that certification program. It's small. It's a 7,000 or 9,000 square foot building. But it does have a dashboard online. If you Google it, Hitchcock dashboard, it's really, really interesting. You can see every single day what the water flows are, what the energy flows are, and sort of see how the building is living. So for this building, it's zero water because it captures rainfall. That rainfall is used for potable purposes. And otherwise, it's got quite a lot of landscape to be able to manage the rest of the water cycle. For urban projects, this is much more difficult. So I think the net zero water is great. It's fulfilling a lot of excellent things, but it is at a sort of microcosm, and there's a huge amount of benefit to thinking about water at the scale of the infrastructure, and at the scale of the system, where buildings are connected, and we do benefit from the diversity of those buildings. Another way of thinking about this on a recent project was to understand on the left-hand bar all of the different water supplies that we could capture to reuse at sort of least at the bottom to most at the top level of intensity of treatment required, and therefore energy and additional emissions. And on the right-hand side of the screen, specifically looking at non-potable uses, and in this case, targeting the cooling tower makeup as one of the biggest issues. We've but we've started to look at the idea of water cycles for buildings in 2 different ways. Number one, on the left-hand side of the screen, actually net zero water, zero city potable, zero discharge, everything gets sort of reused within its own cycle. And on the right-hand side of the screen, a different version where it's zero potable water use for non-potable purposes, which ultimately can have a reduction of something like 80 to 90% less potable water use for all of our buildings, while still being able to potentially tap into the infrastructure that's available for clean drinking water, wastewater treatment at the city scale, and ultimately some of the efficiencies that that infrastructure does actually provide at a system scale. So this is just a diagram to reiterate the different levels of treatment, from rainwater and condensate needing a relatively low amount of treatment to be able to reuse it, gray water needing the next level of treatment, and then black water obviously needing significantly larger amount of treatment to be able to reuse. In addition to mechanical treatment options to be able to reuse the water in buildings, there are also natural water treatment options. This is an example from the Port of Portland in San Francisco, 200,000 square foot building, processes 5,000 gallons per day. It's a relatively small footprint in terms of the system itself, and it sits in the lobby of the building, which is pretty interesting. And there are a couple of different ways of going about this, but the aspiration is to try to mimic the natural system of treating water to be able to reuse it, which starts to be a really interesting blend of the idea of using infrastructure plus mechanical solutions as well as natural solutions for more of a hybrid approach. There are some examples, again, locally of projects that are starting to look at how to optimize the water cycle on their sites. The Volpe project in Cambridge that Matenco is developing includes a really, really cool, exciting version of a water cycle on site. They are, as shown, connecting to the city system for potable water, and they will be connected to the city system for outfall when needed. But otherwise, the goal is to be able to maximize the amount of water collected on site to be able to use for non-potable purposes, so that potable water is really only being used for potable needs. In addition to that, there's a potential connection in the water system to the energy system, which is another potential benefit of thinking about the question of water as a circular economy, and not necessarily what that means that you just handle everything on site and you're an island, but that you're part of a larger system, and there's a way of thinking about the inputs and outputs of that system to be beneficial to the whole and beneficial to a larger group. And there are quite a few of those benefits available. One example is a system of using a heat exchanger on the municipal sanitary sewer line. So you essentially create a bypass for the sewer line, open the valve, the effluent in the sewer line comes onto your site. You have a heat exchanger there, and you can either pull heat off of that or reject heat to it as part of the heating and cooling system of your building. And the great thing is that that's very, very similar to geothermal, but it doesn't require the same amount of infrastructure to create and therefore be embodied carbon, because the sewer lines in the street already exist. So it's a really interesting opportunity to think about how we can maximize benefit from the systems we already have in thinking about this idea of inputs and outputs. The DC water building in DC is a really interesting example of using that technology. They benefit from basically sitting right on top of the city of Washington, DC's wastewater treatment plant. So they have an enormous amount of sewer line to sort of tap into. So they use that system for 100% of their heating and cooling needs in the building, which ultimately reduces, they're using zero potable water for heat rejection and cooling towers. They're maximizing a resource that's already available, and it's part of this other sort of ecosystem of water and thinking about a broader definition of circular. I did this project a really long time ago, but I thought it was really interesting to bring up just again through the lens of inputs and outputs and using systems thinking to try to understand where we can possibly draw the boundary, which is one of the most difficult questions to answer in this entire exercise. But then to really unpack, like, what are all of the inputs and outputs to a system? So this is, instead of looking at an individual site acting as an island, targeting for net zero water, instead it's looking at a wastewater treatment plant, which if you've never been to a wastewater treatment plant, please go for a tour. They're absolutely fascinating from an architectural perspective, from an engineering perspective, from a systems perspective, like big thumbs up. So this is a diagram talking about what the steps of the process of that system are, but also the inputs and outputs. So there's inputs in terms of sand, there's chlorine, there's outputs in terms of methane, there's solids that go to landfill, there's lime that gets added so that it can be used to be fertilizer. And ultimately what that means is that we can start to look at the physical implications of a system like our water system, so that the circular economy it has a physical footprint, right? So this diagram is showing, sorry, the key is really small. The red dots are municipal wastewater treatment facilities. The size of the dot has to do with the size of the wastewater treatment plant itself in terms of capacity. And then the green is agricultural land, and just trying to, like, let's take a look at what the synergy or trade-off is between these two systems. Similarly, we can start to look at chlorine. So where are those wastewater treatment plants? What are their capacities? Where are the salt mines? And what are their capacities? Where are the chlorine manufacturing plants? And what does that look like? And this is where the boundary starts to explode, right? Because it just could go on and on and on and on. But it's an incredibly interesting exercise to think about from the point of view of circular economy, because we do have to draw a boundary around something. And naming that is one of the most important parts of the process. Some additional examples of that type of study. Similarly here, the pink crosses are lime plants. The wastewater treatment plants are still in there, for example. And then there's locations for crushed stone quarries, other stone quarries, and the types of materials, right, that are being used to actually harvest the lime to be able to put in the wastewater treatment plant with the solids, so that the solids can be used as fertilizer as part of the circular economy of a wastewater treatment plant. Super fascinating. This is just a capture of all of those different studies in terms of trying to think through some of the variables, not all of them, but some of the variables and how they start to correlate potentially with each other, how they line up, what does that mean for planning, for design, for architecture, and for our built environment. I wanted to leave you with this because it's just really interesting. Because the water and wastewater treatment plants is warm and it never freezes, there are migration pathways that are specifically related to the location of wastewater treatment plants in North America. Super interesting. And when I visited the Ann Arbor wastewater treatment plant, the engineer there told us specifically that he doesn't eat duck anymore because the ducks are so often there. So with that, have a think about ducks. Vegetarianism is great, just in general. And thanks for your time.
Thank you, Judy. That was really interesting. Rethinking waste and water has literally been the core of a lot of studios here at the GSD, and that really opens up new ways of thinking about this. So thank you so much. I'd like to now invite our two guests to join us on stage for a panel discussion. So we spoke very briefly about circularity and approaches to circularity. And today I wanted to open up the discussion by really understanding what is the dimension of the circle. What is the scale of this circle? Are we saying that we're going to address this global issue by starting very small, starting very local? So I just want to understand from both of you, what is your perspective on this dimension of the circularity initiative?
All right. Yeah, that's a tough question. I'm sorry about that, but I think that it's really interesting when you think about building materials and circular economy because especially for historic and traditional building materials, they're local typically, and they perform and respond to the local environment they're in. So, thinking, for example, timber becomes acclimated to the sort of temperature and humidity of the location where cars have been installed and used, or stone, types of stone that are used to come from local quarries and respond to local environmental conditions. So I think there's some potential limitation to how far you want to move materials, as well as, sort of the transportation impacts of movement. But I think particularly when you get into more contemporary materials, it's a really interesting opportunity. I think that idea of a material bank, or, how we can think of that tracking, which is a huge challenge, does provide an opportunity to expand the circular economy to kind of a global built environment. Although that kind of raises the question for me of what's the right level to do that at, to really maximize benefits for local economies, or like trades, how the way trades work in different locations, and again, the environmental impacts of having to move and store materials across that large application.
I would add to that some of the maps that I was showing are really interesting. Were a really interesting starting place for me to start to think about the same thing, right? Which is ultimately like, where are the raw materials available for this thing, and what is the responsible distance from that source to distribute it? What is the responsible amount of energy to put into manufacturing that raw material? Is it something we should even be doing moving forward? So the physical distance, the physicality of the systems, I think is a really interesting question. On the water side, I think, we're working on buildings that are going for Living Building Challenge or Net Zero Water. There's some really incredible ways of thinking about goals for projects to be more responsible stewards of water as a precious material. But at the same time, I think that like the watershed should be the boundary, right? Or not should be, but could be. I'm not gonna say that that's an answer. The watershed could be a very straightforward boundary condition for the idea of a circular economy for water, because it represents a natural system that without interference has already been a circular economy. So I think there's another, materials are harder because they weren't naturally extracting themselves in the past, right? On the water side, there are some existing boundary conditions that actually give us clues.
Thank you, Julie, Laurie, and Christina. Thanks for sharing your perspective with us, and really, your insights were they've been thought-provoking. So Christina spoke to us about the use of digital technologies. Laurie spoke to us about carbon, and honestly, this is the first time, at least I have heard somebody talk about water as being circular in a public listing. So, that was very interesting to hear. So I have questions on all of you, but I'll ask you what Christina was kind of focusing on. She mentioned the use of digital technologies for enabling circular economy. I'm not sure whether it's still on an experimental basis or have we taken it commercial, but that's like Zurich that she's been talking about. Have we started using digital technologies to the benefit of circular economy here in the US, and especially in your respective work? And if yes, how? Give us some very possible.
Given the answer, I don't. I'm gonna think about that.
Well, I can jump in. I think not really to the extent that there's obviously huge potential there that's untapped. We have started to use digital, I guess, mapping and sort of data collection as a way to match essentially between materials that exist in places that need materials. I think there are still huge gaps, and I question. I come from a totally different perspective because I do a lot of work with historic buildings and preservation. And from there, we like to advocate for not making these things digital. And so it's kind of a question of in what ways is that beneficial and what ways is it a little bit dangerous. And I think the craft of buildings, thinking about design for deconstruction, for example, that can be done by hand or it can be done by machine. And what's the right place to use either approach? I do think using digital technologies just for mapping and for communication and for creating a sort of infrastructure for the circular economy of buildings is a huge opportunity.
Yes, I think to the data part of her video, totally agree. There's a lot of information that's being collected today. The scanning buildings, point cloud models, like all of that is definitely in play when we're working in an existing building. That's becoming a pretty standard practice. But more from the perspective of trying to understand where things are rather than what they are, so that we can coordinate around them. So I think there's definitely a shift that's needed there. But I also think that we're in a really interesting moment in architectural practice, in the building environment, in the building industry, because as Lori noted, the idea of building for deconstruction means that if we all started on all of our new construction to use the information that we have in our models, because the contractors are bidding based on quantity of materials. If we put that somewhere, if we had a database of materials for buildings and started to require that all buildings put that information together, that could actually start to facilitate some of the things that Catherine was laying out in terms of the idea of understanding what material might be available, how it could be distributed, where it's located, etc. That feels and seems like a huge undertaking. But the interesting thing is that we do actually, on a building by building basis for reconstruction today, have all of that information. So in 30 years, 50 years, 70 years, it could be there.
Excellent, thank you.
Follow up to that, I'd like to direct this to you first, Laurie. You spoke a lot in your presentation about reusing building materials and buildings itself. And today in our built environment, I think that we can share a lot more than we currently do. We've already looked at systems where, in transport, for example, where there is a shared model working, where you're not taking ownership of a product, but you're really renting out a service. And I want to understand, is there scope for any entrepreneurial solutions to lease out building materials as well? Just the material aspect, can that be leased out?
That's a really interesting question. I'm thinking, I'm taking a second to think about that. Oh boy.
And that does happen with carpet tiles. So you,
Yeah,
think about
that's-
like finishes,
Right.
right? That's an obvious starting place.
Yeah, I think it's interesting to think about. I wish I'd shown this diagram this Grant Stewart diagram of the levels of a building and their life cycle. I think starting with structure, which has the longest potential lifespan, down to the finishes where, things in a building which we go through, we cycle through very quickly. And things like carpet tiles, things that are turned over more quickly, but represent a much smaller carbon footprint within the whole building. I think we're starting to see things like that because they're used for so little time. They're take back programs. And so I think that's interesting to think about what the term of a lease would be. I guess so I'm thinking about that and how that ties to how long you actually want to promote something staying in the building. The structural system, I think that's like a real long-term lease because that could be hundreds of years, but that stays in place as opposed to carpet. So your example, which people get bored of every 3 years, or a new tenant moves in and they have a different taste.
I think it's also incredibly closely related to how Catherine is thinking about her work, right? So if we think about the idea that we could build a database today that starts to capture all of that information, you could not only think about how once those materials are loaned out, they're loaned out for a specific amount of time, but they're also priced according to natural capital instead of the traditional economic market system. So Paul Hawken wrote a book called Natural Capitalism. If you haven't had a chance to take a look at it, I'd recommend it. But it's essentially, the idea of pricing water, pricing carbon, pricing all of these things based on what their actual value is in terms of impact, rather than just in terms of availability or, whose labor is cheapest and that kind of stuff in terms of typical economic market flows. So I think it could easily get there. Right now, it's definitely more limited to the idea of finishes and take back programs.
So Sanitary, I can help you there. There are companies which are now leasing out the facades of the building. Right. So the building concrete is separate, and then the facade is being given out on lease. So that's really happening already. More from a financing point of view rather than anything to do with circular economy. Very good. So for you, Laurie, you mentioned that, if I heard you correctly, that so far only 2% of the existing buildings have been converted into carbon neutral or green buildings, like how you want to tell them. So 90% is still remaining, and that's a big stock. So, and that's the challenge in front of us. How do we make them green? So is there anything happening on the policy side? Are the cities taking interest in it? Love to hear your thoughts on that.
Yeah, absolutely. And it's 2% annually. So it's more than 2% total, but it's just a slow piece. And it's definitely becoming a huge policy focus. I know Julie and I are both involved with this locally, but for example, here in Boston, we have the BERDO, there are basically a lot of disclosure ordinances which are requiring building owners to disclose how much energy they use and then to reduce that over time. Or in New York City local law 97, which is a little bit further along than we are. I think that we're starting to see these policies emerge. I think there's still a huge gap around implementation and our guidance to achieve this level of decarbonization without maladaptation, without huge carbon emissions, social implications of for example, spray foam insulation, or thinking about the way we achieve these decarbonization targets. And then there are huge gaps with anything designated historic here in Boston. In New York, they're not getting away with it quite as much, but I think we leave a lot, we leave a lot on the table when we say that these buildings are too challenging to upgrade, so we're not gonna do it, or it's too contentious to upgrade them. So, we are making progress, and we have a long way to go. And Julie, I know you're really involved in this also.
Yeah, I mean, I second everything you just said. The Bird 2.0 program through Boston is super interesting. It's the city of Boston said we're gonna be carbon neutral by 2030, and they finally rolled out this policy that says now that we've collected all of this data for X number of years, we know what the average building for all of these different building types looks like. So here we are at our starting place. We know what that looks like for carbon emissions and energy. We want to get to zero by 2050. So here's what's required in 2025, 2030, 2035, 2040, and buildings have to comply. If they don't comply, there's a penalty. So there's a real incentive now, and there are I think there are like 6 or 7 of those in North America for building performance, specifically for building emission standards requirements that actually have a financial stick.
Just building on the idea of policy and how cities should really adapt to this. I mean, I come from an urban design background, and this has sort of been a major question for me for a very long time, that cities differ in terms of their economic production or in terms of their manufacturing capabilities. And there are very vast and very significant differences between the cities of the global north and global south. There are some developing countries which might not have the right resources and technology to really move towards a pathway to circularity, and where you might have some developed countries which are actually doing the manufacturing of all the products that we're using globally. So is it fair for this pathway to circularity to sort of pan out equally in the world? Where do we start, or who should start this, or is this fair to put the onus on all the countries together?
There's a lot of dialogue around that, more from the point of view of carbon emissions than from circularity. And there's a general consensus that the developed countries are more responsible because we've had the benefit of doing all of the dirtiest deeds, right, to date, and we've benefited from all of that. So there is more burden on the countries, on the companies who have benefited from not having those restrictions in place, so that the countries and companies, et cetera, who are not yet there have some more leeway and or have market-proven solutions that have been developed by other people. So I would say that no, the burden is not equal, nor should it be from an equity point of view.
I completely agree. And I think we have a dual challenge with thinking about how we manage the built environment in the near future, because on the one hand, we have this sort of rapid consumption in the developed world, particularly in the global north, which we're trying to decarbonize and somewhat failing to do because we don't want to sacrifice our lifestyles here. And then there's a lot of the world that still doesn't have the same standard of living, and so it's obviously completely unfair to tell them you're not allowed to develop because we can't emit carbon. So I think there's the challenge of both, bringing a quality of life to many people while sort of suppressing growth and just rampant consumerism in the global north. I know the World Bank is doing some pretty interesting work around this. They have a tool, Edge, you know what I'm talking about? The Edge tool? Yeah, okay, is that what it's called? Which is actually sort of a quick life cycle assessment tool, which allows for finance to kind of follow this to the real estate industry globally to be able to support and incentivize more sustainable development, even in places where there isn't an infrastructure that supports it inherently or regulation to help with that.
I just want to quickly jump in and remind everybody who's joined us virtually, please post your questions in chat. We are monitoring those as well.
We are sitting in the Graduate School of Design, and hopefully on Zoom and here we have some great designers. So my question is, as you kind of move towards making buildings and whatever you other things here, design more circular in terms of carbon footprint, in terms of water. Do you have to compromise with the aesthetics of the building? Where does the balance lie?
No, sorry, there's no compromise, but this is the kind of question that I deal with on a daily basis, even with my own colleagues. I think it's just a design challenge, just a really wonderful design challenge to figure out how to, what is the new architecture? What's our next movement in design that embraces circular economy and overall with this desperate need for climate action as a driver? And what does that mean for aesthetics? And I think that's there's something with the architect's ego that maybe we have to think about in the way we approach that. But I think there's so much space for creativity, both technological and design creativity in the way we move toward the circular economy. I don't see it as eliminating that artistic expression or that individual expression at all. I think it's really just a huge design challenge for all of us.
Totally agree. Yeah, something again for us designers. Yes, when we go back from here and inspired about how to really make the shift towards this in our designs, do you have any ideas in terms of parameters of how we can sort of evaluate or like quantitative as well as qualitative methods of really, for us designers to relook at our projects and where do we start in terms of assessing that our design is probably going to be the start of change in terms of circularity.
So, Lori's been building this really amazing tool called CARE, which is going to be coming out pretty soon, and that's an exceptionally helpful high-level calculator to be able to look at the carbon value of new construction versus existing buildings. So I'll let her talk about that a little bit. But I think in terms of at the very start of your career, the question of materiality in design is so fundamental to what we do in the built environment that I think the starting place is to think more carefully about what a material is, and instead of only asking what the material can do aesthetically, there's a question about what are the other impacts of material choice that need to be considered. So we need to expand the checklist of the questions that we're asking ourselves as we're selecting materials. There are a lot of really good databases and information out there now. There's still, a huge amount of opportunity for those to be even greater. But there are, the Payette has developed a tool called Kaleidoscope that gives some really interesting high-level information about facade types and what different materiality and facade expressions could look like. There are some really basic pieces of information on the internet that if you just Google it, you'll find something about, the average impact of steel versus concrete versus timber. So there's a lot of information out there. I think the ask is that designers, like Lori was saying, really take this on and start to really, from a systems thinking perspective, from a circularity perspective, think about the whole picture. Every time you're making a decision, understand all of the different variables and impacts to the best of your ability and take those into consideration.
So, Julie, my questions to you. I was very excited when you spoke about water, net zero buildings. So I wanted to size the problem. How big is this problem? So would you have any measure that per cubic meter of built space or something, how much of water is consumed? Some data points so that we can.
I don't offhand right now. I can say that, like I said during the presentation, if we address the non-potable needs in buildings and stop using potable water where it's not needed, there can be a 70 to 90% reduction of potable water use, and that, let's get there first, right? Like that is the biggest opportunity for all of us to consider. And it's relatively straightforward in terms of capturing water on site and reusing it on site. I think that, you know, in terms of like how big is the problem, my brain before you asked about the metric per building, and there is a metric called water use intensity that's very similar to energy use intensity. And there are databases that collect that, and you can look up like what is a typical building use for water use intensity. The 2030 district program targets a reduction in water use intensity the same way that they target a reduction in emissions and energy. So I know that Pittsburgh, for example, has very specific information about where their buildings are on average and what they're targeting moving forward. But my brain immediately went to Australia when you said how big is the program, right? And other climates where we're building a crazy amount of built environment and with a complete lack of natural resources at the ready, and the amount of energy that goes into desalination plants and other infrastructure to create the resource that we need in that place. I think that like that's another moment for me in terms of trying to conceptualize the like how big is the problem, right? And I like that opens the door to talk about resiliency and whether the city of New Orleans should even be where it is among many other cities, right? So there's this, again, the physicality of the system has this real question about place and urban design and like where are we putting ourselves and are we putting ourselves in danger from a resiliency point of view, not just from storm events, but from access to natural resources that we need to live without bending over backwards to make it happen.
We just have a few minutes, left, so I want to open this out for our audience. If there's anybody who has a question. Could you share them?
Also, you guys are rock stars for hanging out with us this long. Thank you.
Hello, okay. Hi, I'm Simon. I'm a master's student not in the Janesski, but in environmental health. There's like a topic that I'm also very interested about. So thank you so much for your discussions. And I have a question for Julia. I'm wondering for like the city of Boston or like other citywide scales, is there anything on the systematic water reservation for building in terms of the community level? Because my understanding is like how wastewater treatment plant works, it cannot have like the impacts over like community-based level, and how is like this kind of like the new application of systematic LCA like analysis input into impacting or like taking challenges from communities, and that would be very helpful if we could have some like insights on me.
I'm gonna try, and you should let me know if I'm answering the question that you're asking. So in one of the graphics that I showed, there's what's called areas of concern, AOC, that are specifically related to wastewater treatment plants, but more from an industrial point of view. So there's a couple of problems that we have in the water infrastructure that we have currently in place in a lot of cities. One of them is where the sewer system is combined with the storm system. That's called a combined sewer outfall, CSO. And where that exists, typically when there's a huge storm, the stormwater flows into the system. The wastewater treatment plant gets completely overwhelmed and it can't manage the amount of water that's coming in. And therefore the doors open and everything just goes into the river or the body of water that it's dumping into without the treatment that's intended. So getting rid of the CSO systems is something that a lot of cities and communities have been working on over the past few decades. And is a really critical move to protect the bodies of water that we're putting effluent back into. The quality of treatment at wastewater treatment plants has been improving from a typical wastewater treatment plant point of view, but again, from an industrial point of view, the areas of concern that was on one of those maps that I pointed out is where there are lots of industrial plants and companies that are doing nasty things and not getting penalized to the extent that they're stopping. So there's a huge amount of opportunity there, and I think there's a really important correlation between where those events are happening and where there are communities that are more vulnerable, very similar to manufacturing and pollution from carbon point of view. So from an equity stance, there's a real concern. And to your question about, those who have and those who have not, there's a real disparity between where that's happening and how much power or authority or money the communities that are most affected actually have to do something about it. I was born in Flint, Michigan. I grew up in a small town pretty close to Flint. The situation that Flint has is everywhere. Flint got on the radar and made it public. The lead pipes are everywhere, and we have a huge opportunity, right, to continue to look at that. So I'm really hopeful that the current administration in government and future administrations in government can incentivize improvements in infrastructure, because that's what's really, really needed to be able to address some of those issues at the community level. Otherwise, I would say that the next best thing is for communities to take on the issue the same way that they're taking on climate action, learn more about what's happening specifically in their neighborhood, and start to speak up. Does that kind of answer the question?
Yes, thank you.
Okay.
Well, thank you so much for coming and generating this space for conversations. I was actually talking to Sanitary that, again, like introduced in the beginning, the whole notion of circular economy it still is a bit, I'm in the process of digesting all this information. It's a bit abstract, but Catherine in her video, and also you in some spaces, brought up the inquiry of convenience and how can people start associating your practices and the whole idea of circular economy as a convenient component to incorporate in our daily lives. So I was just wondering, how do you envision like people embracing it, and like how can it be convenient for people to stop our current practices or the way we conduct ourselves in the world towards this wave of rethinking the way we build, we live, and coexist, I guess.
I think there's a lot of infrastructure that needs to be put in place. Currently, the way materials are procured is just largely driven by cost and schedule, almost entirely driven by cost and schedule. And we started to make some sustainability, put some bounds on it. But I think it comes down to making materials affordable and making them available quickly. And that there are a lot of just challenges to make that feasible. And one of them has to do with quality. This is one of the biggest questions that comes up when we talk about getting circularity within building materials. When building materials come fresh from a manufacturer, they're warranted and they're quality controlled for a factory setting. And when you take them out of the building, put them into another building, particularly, Julie mentioned, we can start to in new buildings, we can start to, create a bank of that information. So in the future we have it, but right now it's an unknown. And so what's the mechanism we have for ensuring that a piece of cabinetry you take out, or a piece of steel, or a piece of wood meets the criteria we need for construction and reduces liability. It's also a storage, a space problem, because where you put all this stuff, and this is something that comes up in Boston a lot, and the city of Portland just started to figure it out. But if you deconstruct a building and it doesn't have an immediate home for materials to go to, who is responsible for paying the cost of storing those materials? So those are just a couple of my the biggest logistical challenges I hear that are really, practical ways we start to overcome the barriers.
I think the bigger question is attacking the culture of convenience, unfortunately, and trying to undo some of what we've all been accustomed to as what counts as convenient. So, plastic bags at the grocery stores have already started to get around that. Lots of people carry bags. Reusable or reusable containers, right, versus a single-use plastic container. That's something a lot of people are getting used to. I think, and I don't have a solution for that, but I do think that that's right at the, like, that is the root of the problem. And I think that's where that's where I hope we can spend a lot more effort focusing when it comes to the individual, like all of us individually and what we're doing, is how we think about the problem and less about whether or not I happen to put that in my recycling bin or not by mistake, and the amount of guilt that I should feel about that, right? Because the problems that we have around water and carbon and emissions and climate action are fundamentally driven by industry, by manufacturing, by extremely large, complex systems. And the act of every single individual is ultimately less, in my opinion, less about our recycling bins and more about the way that we're thinking about the systems and trying to change the way that we think so that we can drive the market, so that the industry and companies stop doing the bad stuff.
One more thing to your point earlier about true cost. I think that's another big problem here is that we do go for what's least expensive oftentimes. And especially from an equity standpoint, projects that, you know, for example, affordable housing, which is often those are the lowest budget projects, they have to, by necessity, go for the lowest cost materials. And the cost is based on people being allowed to use really dirty energy, people being allowed to use exploitative labor, you know, all of these things. And so I think from a regulatory perspective, if we can shift the economy to better reflect financial cost with dollar cost with the environmental and social costs, I think that's also a really important, you know, change that we need to see.
Sorry, just to add to that, I think the biggest driver would be economics. People's habits change when anything that they consume meets their cost expectations. So as the industry grows and economies of scale build up, I think we will reach that point where people start flipping over. Also, I think policy plays a tremendous role. So somewhere or the other, the government has to step in to drive that behavior. And third, I think, as Julie also mentioned, is that people have to become conscious. They have to adapt. And once they do, then things will move. I also heard Julie talk about there are some big culprits. So just to give you an idea, the cement industry alone contributes to around 8% of the greenhouse gases.
Globally.
So if we are able to control that, you know, imagine the amount of carbon dioxide that we can control. Similarly, steel and fertilizer, these three put together contribute over 22%.
Concrete, steel, and aluminum are 23% globally.
So,
I know that, but I don't know the water question. I don't know why. I also say, you know, there's something, so Starbucks, for example, right? They charge extra if you want oat milk or soy milk. Why? Like, it doesn't actually cost them more. There's so many articles coming out about this right now, and it's just, there's a lot of really simple opportunities, like in our daily lives, to push back to some of these places and just, you know, start to, and I don't know what the pushback looks like, but I'm pretty sure we could all get Starbucks to change that if we put our minds to it. And shift, exactly, right? Like, what is the medium? Do you want to spend 50 cents more for oat milk, even though it's massively better for the environment? I mean, I do, because I'm like almost lactose intolerant now, but as a general practice, you know, at like removing the barriers, I think is sort of the general theme that's happening up here. Identifying them first and then removing them. And the people becoming conscious things, like, it's such a chicken and egg problem, right? Because people exist at lots of different levels of human consciousness. I'm pretty sure all of us in this room right now are pretty comfortable in our lives, and we don't spend a lot of time being driven by fear in terms of the decisions that we make every day. That's not true for a lot of people. And it is not fair to expect those people to have this kind of conversation and potentially make sacrifices in addition to everything else that they're concerned about, right? So it's like there's this question about equity and justice, that absolutely has to happen at the same time that we're talking about all of this, which comes full circle back to your question before in terms of the burden of really trying to figure out how to actually make some of this stuff happen.
I'm just going to intervene over here. Wait, have that question. All right, we've run out of time. This has been a really productive session. I'm just rethinking waste, rethinking how we can design for disassembly or for reuse. And I think that I really hope this is going to be the start of many more conversations and many more calls for action as well. We at Circular Economy Symposium, we have a lot more events lined up, so please stay tuned. And we'd just like to thank once again Women in Design, Hughes, our panelists, and our audience for joining us today. Thank you so much for being here.